So we're just doing this as polynomial. We're not going to do the sinusoidal part of this. We're on page 331. So polynomial functions. A polynomial function consists of one or more terms which are separated by plus or minus signs. So one or more terms separated by plus or minus signs. That's a key thing to a polynomial function. So in grade 10, you looked at linear ones where it was like y equals mx plus b, right? So y equals 2x plus 7, stuff like that. Then last year, no matter what grade 11 class you were in, you looked at quadratics, which were like y equals 3x squared plus 2x plus 7, okay? This year, we're going to add to it degree 3 trinomials. So we've done degree 1, degree 2. We're going to also do degree 3. So we've already met polynomial functions in one variable in previous mathematics courses. For example, this is a what? X squared minus 4x minus 5. What is that? What kind of polynomial? It's a trinomial, but also we called it what last year? Nope. Starts with a Q. Quadratic. This one is a, starts with an L. Linear, because it makes a line, right? And then this is a constant. This is the same. Remember, f of x for the most part is the same as saying y equals 3. The reason why we use f of x instead of y is because we do functions like we did in grade 10, where I'm going to give you an actual x value that you have to solve for, right? So you do f of 5, let's say. So it would be f with brackets of 5. That would mean that you have to fill 5 in for every x. So that's why they use that format instead of just a y. So now we're going to go over degree. The degree, because I might be able to ask you about a degree. They might also ask you on the diploma about degrees, so we're going to pay attention. The degree of a polynomial function is the value of the highest exponent. The degree is the value of the highest exponent. If a polynomial includes a term with no variable, then it's called a constant term. No variable means constant term. That's degree 0. So when it was y equals 3, that would be degree 0. Because I could write it as 3, and then I could put an x to the 0 behind it. Why could I put an x to the 0 behind it? What's anything to the exponent 0? Nope. 1. Anything to the exponent 0 was 1. So if I went 2 to the 0, that would be 1. You learned that in grade 10. If I went x to the 0 behind that, that'd be 1. So it would just be 3 times 1. So it wouldn't change anything. So that's why it's degree 0. So we're going to look at A. Complete the following. The degree of f of x equals x squared minus 4x minus 5 is what? What's that degree of that one? What's the largest exponent, Kale? What's the largest exponent? X squared minus 4x minus 5, Kale. What's the largest exponent? Exponent is the raised number. The high number, the tall number, the large one. It rhymes with foo. Yes, 2. The constant term is the one that remains constant. The only term that's going to remain constant is the one that doesn't have a variable on it. Because if a term had a variable on it and you were given that x equals 2, you plug a 2 in and it would change it, right? The constant terms are the ones without variables. So you might want to write that for yourself. Constant term is the term without a variable. So, what's the constant term in that one? -5, yeah. You take the sign with it. So the second one, the degree of f of x equals 2x minus 4. That x has what exponent? What number? 1. So it's degree 1. The constant term is what? -4. So f of x equals 3 can be written as f of x equals 3 to the 0. The degree of f of x is 0. A number that multiplies a variable in a polynomial is called a coefficient. So any number that's in front of a variable is just a coefficient of that variable. Okay? There's a special type of coefficient. It's called the leading coefficient. The leading coefficient is the number that multiplies the term with the highest power. So a coefficient is the number that's in front of any variable, right? So if I had 3x, the 3 would be the coefficient. Or if I had 7x squared, 7 would be the leading coefficient. If I had negative 2x squared, negative 2 would be the coefficient. The leading coefficient is the one that's in front of the coefficient that's in front of the highest power, the highest exponent. So the leading coefficient of f of x equals x squared minus 4x minus 5 is what? What's the number that leads this? The number that's in front of the largest exponent. Yeah. 1. It's the number that's in front of the x squared because the x squared is the highest power. And if there isn't a number in front of x squared, the number is 1. Okay, you can put a 1 there. You can't put a 0 there because 0 times anything is what? 0. So if I put a 0 in front of the x squared, it would just cancel and go away, which is not good. The leading coefficient of f of x equals 2x minus 4 is what? 2. What degree is this? 1. What is the constant? Negative 4. In a polynomial function, all the coefficients must be real numbers, and all the exponents must be whole numbers. Write a polynomial function that satisfies the following conditions. Degree 2. So what does my largest exponent have to be? x2, x squared. And the leading coefficient of negative 3, what does that mean? The negative 3 has to be in front of the x squared. So I could just go negative 3x squared and I'd be done. Can I add more to it? Does it say that there can only be one term? Because if it said there was one term, I'd have to stop here. So that's one term. Terms are separated by plus or minus signs. Okay, so that's one term. But it doesn't say that it has to be one term. So I could add a plus 6 at the back and I'd still be correct. I could add a negative 7x in the middle. I'd still be correct. Okay? Degree 2, leading coefficient of 7, has 2 terms. So now it can only have 2 terms, like the top one had. Okay? Degree 2 means it's an x squared. Leading coefficient of 7 means it's a 7x squared. And then I could add 2x. Could I add a minus 3 at the back now too? No, why? It says 2 terms. Do I have to have a number at the back without a variable, a constant? No. This is still correct. What is the constant on that in that equation? 7x squared plus 2x. Nothing, which is also known as 0. Okay, you guys try these ones out. The last 3. Degree 1, leading coefficient 1. Anyone have an example? Degree 1, leading coefficient 1. Yeah. 1x plus 6. Could I have just put 1x and been right? Yes. Could I go 1x minus 1,000? Sure. Degree 0. Any number. Just can't have a variable. So I could go minus 7. You could have went 22. You could go 10. You could do a fraction, 1/3. You just can't have an x on it. Degree 3. Degree 3. So I could go 3x cubed. Could I go negative 3x cubed? Yes. Could I fill an x squared and x in the middle as well? Sure. I could go minus 2x squared plus 6x, or I could not have those at all, because those are not important, right? The x cubed is important. So literally at this point, I just need to have an x cubed. But what else do I need? Constant term of minus 8. What does that mean? Subtract an 8. Does it have a variable on it? No, because it's a constant term. So minimally, I could have just went x cubed minus 8, and I would be correct. Okay? It doesn't need to be fancy. Next page. So we're going to look at degree 0 functions. So we have f of x equals 3. So that's a horizontal line at 3, right here. It says state the domain and range of f of x equals 3. So domain is where the x's exist, okay? So if I can find an x value for every single x value, it's going to be x and m of the reals. So for this line here, my arrow is going all the way to the right and all the way to the left. So if I said, is there a value for when x equals 0? You'd say, yeah, right here. If I'd say, where is there a value for when x equals 5? You'd say here. Is there values in between all of that? Yeah, what about x equals 100? Could you give me an answer for it? Yeah, it'd just be like down yonder, but it would still work, right? What about negative 1 million? Could you give me an answer for that? Yeah, all the values in between? So basically, I can find an x value for everything, correct? If I can do that, then my domain, you go domain, little d, and then you go a little squiggly bracket. The little squiggly bracket, I'm not going to mark you based on if your squiggly bracket is a very nice squiggly bracket. Like, try and make it as nice as you can, but you're not going to, like, fail math 3-2 because your squiggly bracket isn't pretty, okay? The squiggly bracket means the set of. It actually means something. That's why you do the squiggly bracket. It means the set of values of x. So you do an x, because domain is always x. If you can't remember, domain, x, range, y. If you draw a line under domain, it doesn't cross anything if you use x. If you draw a line under range, both of them have little tails. Okay, domain, x, range, y. All right? Now, x such that. You draw a straight up and down line because it means such that. Every single thing I'm not drawing just for fun. They actually mean something. So the squiggly bracket means a set of x values such that x is an element, this little c with a little dash, you should have seen this before, of R. X is an element of the reals means every x value that I can come up with, I can find on this graph somewhere. Okay? So if your arrows are going out in opposite directions, even if they're a little bit of a tilt, they're still going out forever this way and this way, there's no gaps in the middle, it's going to be XER. Okay? Now the range. Do I have y equals -5 on this graph somewhere? Can I find y equals -5 on the graph somewhere? Is the graph crossing through here ever? No. Is graph crossing through y equals 0 ever? What about 1? What about 2? What about 5, 6, 7? Is it on any of those values? What's the only y value I have? What is it going through? Y equals 3. None below, none above. That's it. So the range is y equals 3. So it's going to be squiggly bracket such that y equals 3. That's it. That's the only y values on that graph. The horizontal line going through all the 3s. That's it. So constant functions always have a range at y equals whatever the heck the constant function is. So write two other functions with degree 0. So let's do, I'm going to do g of x equals -6, and I'm going to do h of x equals 0. This is the other reason why they use f of x instead of a y. They use it so that you can actually label your equations with just g of x or f of x or h of x, and you'll know which one's which. If you labeled them all f of x and you labeled them all in the graph f of x, which one would it be? I don't know. They're all labeled f of x. So g of x equals -6. So I go to -6 and I draw a horizontal line because this is crossing through y equals -6. So that's my g of x graph. And then my h of x graph is when y equals 0. Y equals 0 on the x-axis. X equals 0 on the y-axis. Okay? So y equals 0 on the x-axis. This is h of x. And I don't even need to write the equations out at all. I can just label them g of x or h of x, etc. So, sketch and label them on the graph, the grid, which I did. Describe the general shape of the graph. What are all these graphs? There's certain types of lines. What kind of line is it? They're straight lines, also known as horizontal lines. How many y-intercepts do they all have? Each one separately? None, because they're horizontally crossing through the y-axis in one spot, right? So they have one y-intercept each. Bless you. Do any of the graphs have x-intercepts? If so, state the function. If not, can you find a degree 0 that does have x-intercepts? Do any of these cross the x-axis? Does the f of x equals 3 cross the x-axis? It's a horizontal line at 3. Does it cross the x-axis? No. What about f of x equals negative 6? No, it's just at negative 6. What about the f of x, or the h of x equals 0, 1? Is it on the x-axis? Does it have x-intercepts? X-intercepts cross the x-axis. Is it on the x-axis? Yeah, it is infinite number of x-intercepts. It's on the x-axis. The x-axis is where the intercepts exist. So the x-intercepts exist on the x-axis. This thing has infinite x-intercepts. So the only function, the only constant function that has x-intercepts is h of x equals 0. And it has an infinite number of x-intercepts. Describe the relationship between the equation of each function and the range of each function. So the f of x equals 3 function, the range was y equals 3. So the h of x function, which is at 0, the range would be y equals 0. And the g of x function at negative 6, the range would be y equals negative 6, right? So describe the relationship between the equation of each function and the range. The range is y such that y equals the equation. So for example, if you had k of x equals negative 7, the range would be y such that y equals negative 7, because that's the only y values that exist on this equation. It's just at that value. So we're going to generalize the above work to complete the following statements about all polynomial functions degree 0 in the form f of x equals c. We're just treating it as f of x equals c, some sort of constant. Instead of writing for 7 or 6 or 5 or 3, it's just going to be for c, for all of the values that c could be. The graph is a what line? What kind of line do we get when it's f of x equals 3 or 6 or negative 2 or 7? What did you guys tell me? What kind of line did we get? Horizontal. It has a slope like Saskatchewan. With a slope of what? It's flat, so slope of 0. The domain. The domain is every x value in the world. So what's the domain? Yeah. X such a x is an element of the reals. This is an E looking deal. It should look like a C with a little line, but mine's getting kind of fuzzy. What's the range? If f of x equaled 6, the range would have been y equals 6. If f of x equaled 3, the range would be y equals 3. If f of x equals c, what's my range? Y equals c. There are how many x-intercepts? How many x-intercepts are there? How many times did it cross the x-axis? That x-axis, that flat x-axis. If it was 3, did it ever cross the x-axis? No. If it was negative 6, did it ever cross the x-axis? No. There are 0 x-intercepts except for the function f of x equals what? What was the one where there was infinite x-intercepts? 0. And there's how many y-intercepts? How many times do each of those horizontal lines cross the y-axis? Once at that y value. Does the value of a polynomial function of degree 0 depend on the value of x? No, it doesn't have an x value in its equation. Since the values of a polynomial function of degree 0 remain constant for all values of x, this type of function is called a constant function.